Okay, students, welcome to this quick lesson in geometry where we're looking at rectangles and area and perimeter. But we're going to be doing all of that with algebraic expressions. That means dealing with things that are not just numbers, but also algebraic stuff like x or x squared. Let's start with things that you actually did earlier in your school with math, where you looked at just using numbers. So here I have something that says a vertical height of 5 and it has a horizontal length of 10 plus 2. Well, first of all, if this is a rectangle, I can copy and paste those measurements to the sides that are opposite them. So I can have 5 on both the verticals and 10 plus 2 on both the horizontals as well. What that gives me is for perimeter, that's just finding the total of all the numbers all the way around. So I could say 5 plus 10 plus 2, and then I got another plus 5 plus 10 plus 2. All right, so 2 5s give me a 10. I have 2 more 10s, and then a couple of 2s, which will give me a 4. Let's do that. Then I can group these 3 10s and say it's 34. You could have used a calculator, done the same thing, been just fine. Okay, now I could say this 10 plus 2 is 12 and do a calculation of 5 times 12. But I want to use this idea of 10 plus 2 to actually split up the rectangle. So that's like saying this section is 10 and this section is 2. And 5 times 10 is 50. 5 times 2 is 10, and I can add those two things together to give me the area. So I'm going to write that over here. I have a 5, and then I have a section that's 10, a section that's 2. The 5 times 10 is 50, 5 times 2 is 10. Added together, that gives me a total area of 60. Let's expand that idea into a rectangle that has just higher numbers and different groupings of them. Again, I can copy and paste these numbers across to the opposite sides. So that's going to give me 4 10s. So I have 10 plus 10 plus 10 plus 10. And then I got 2 5s and 2 6s. So that gives me 40 for the 10s, 10 for the 5s, 12 for the 6s. I got 50 and 12, or 62. So my perimeter is going to be 62. Again, calculators are invited to add just a bunch of numbers together. Let's see how these numbers can be broken apart to calculate the area in pieces as well. So if I have the 10 and the positive 6 here, and 10 and the positive 5, 10 and 10 for my first box is going to give me 100. So this top left box is an area of 100. Now this 10 and 5 and 10 and 6 can be copied all the way around. So if I look at this top right corner, now I'm going to have a 6 and 10. That's going to give me 60. If I look at this bottom left corner, I have a 5 and 10. Multiplying those length and widths, I get a 50. And then the final one here with 6 and 5, that gives me a 30. I have a whole bunch of stuff to add together. I got 100 plus 50 plus 60 plus 30. Put all that together, we should get 240. You might be asking, it feels like we're overcomplicating it. Why can't we just say 16 times 15 and see what comes out of that? Here's why. As we start using algebraic things, it actually helps to separate some of those calculations. So we can see which pieces are getting multiplied by x's, or x times x, or a number times x, or a number times a number, and we can keep it all organized. So let's see this first one. It has 4 for the vertical, x plus 3 for the horizontal. So if I were to find the perimeter, I see that I have 2 x's, I have 2 3's, and 2 4's. So that's going to be 2x plus 6 plus 8, or 2x plus 14. So that's my perimeter there. Now for the area, I notice that we have a 4 for my vertical and x plus 3 for the horizontal. I'm going to copy this 4 on the other side as well. 4 times x is 4x. 4 times 3 over here is going to be 12. That tells me that this area could be written as 4x plus 12. Okay, now let's do some more, but we're expanding to having 2 parts to these dimensions, an x part and a number part. And then we're also going to look at, after that, we're going to look at having not just positive numbers, but also negative numbers. Okay, so let's copy and paste these dimensions around the outside. If I'm going to find the perimeter, I notice that I have 1, 2, 3, 4 x's. So 1, 2, 3, 4 x's. Then I got 2 4's and 2 3's. That gives me 4x plus 8 plus 6, or 4x plus 14. So that's how I'd write that perimeter. I'm adding all the numbers and all the x's, but I'm combining like terms. So all the x's can add up to 4x, and all the numbers can add up to 14. Okay, let's look at what area does for us. For this area, I'm going to have an x plus 3 for my vertical and an x and a plus 4. I'm going to go ahead and copy the x and plus 3 on the other side as well, just so I can have it nearby everything. Okay, in the top left corner, I'm looking at this x vertical height and this x horizontal length. So when I multiply x times x, that gives me x squared, or x to the power of 2. For the next box, on the top right, I have a 4 times x, and we would write that as 4x. I'm also going to put a positive sign there just to make sure I understand that is a positive number. Very similarly, I have 3 times x is going to be 3x, and again positive. This bottom right corner here is going to have 4 times 3. We multiply that together, we would get 12. Okay, so now my total, what I'm looking to do is kind of look for the like terms and group them. And I notice that my x terms, 3x and 4x positive, are going to go together. So I would have the x squared all by itself, 3x and 4x combined to make 7x, and then 12 is also by itself. So there's my total area. All right, let's do very similar thing with this last one, except that I have some negative signs in here. So we have, for my perimeter, it looks like I have 1, 2, 3, 4 x's. So I'm just going to put 4x. But then I have 2 plus 4's and 2 minus 3's. Well, the 2 plus 4's become a positive 8. 2 minus 3's become a negative 6. And as I combine like terms again, I can combine the positive 8 and the negative 6 to become positive 2. So that's my perimeter. It would have been 4x plus 2. Okay, for my area, I'm going to write down these numbers. I'll put an x and then a -3, and then I'll have an x and then a +4. When I do my top left corner, that's going to become x squared from x times x. My top right corner is 4 times the height of x, so that's +4x. My bottom left corner here has a horizontal of x, but a vertical of -3. That's kind of weird to think of area being negative, but it's really just multiplying those two numbers. Okay, now for the final corner, I have a -3 times a +4. So we'll multiply those and get a -12. In this situation, the total area would be x squared by itself, but the x to the first power terms can be combined. So that's going to be -3, but +4. When you combine those two numbers together, that's +1, because 4 minus 3 is a +1. So we have +1x, and then we finish with -12. Okay, all of these were just more of a warm-up for our actual geometric question. So let's take a look at this. It's got a lot going on. First of all, I have a couple of perimeter questions and then area questions. Perimeter, remember, is just adding up all the sides around. Let's go ahead and mark some of the information here. It says HG is x plus 6. Okay. FG is 2x. BC, so that's my vertical here, is this x plus 4. And DC or CD is x minus 3. The perimeter of EFGH, that's the larger rectangle going around the outside. Well, I'm going to have a 2x on each of those vertical sides and an x plus 6 on both the top and the bottom. So I'm going to have x plus 6 plus 2x plus x plus 6 plus 2x. So let's see, I have 1, 2, 3, 4, 5, 6. I got 6 for the x terms if I combine all those. And then for the numbers, I just have 6 and 6. So that's a 12. For the area, what I want to do is take those two main pieces, the HG and FG, so this, and multiply them. So I'm trying to multiply 2x times x plus 6. Now we were doing this with a box, so I'm going to write it kind of in that box format here, where we'd have a 2x times x and a plus 6. 2x times x is actually 2x squared. 2x times 6 is 12x. So this area is going to be 2x squared plus 12x. For the perimeter of ABCD, let's switch to a different color. How about we switch to blue? So for ABCD, we're looking at the inside here. This x plus 4 on the verticals and x minus 3 on the horizontals. So I'm going to add all that together. X minus 3 plus x plus 4 plus x minus 3 plus x plus 4. So I got a lot of things that could be combined. All these 4x's become 4x. Minus 3 and 4, minus 3 and 4 is like minus 6 and plus 8. But the simplest version of that would be 4x plus 2. Excellent. Okay, Okay, now we're at this kind of next big question, the area of ABCD. I notice that I have an x and a number for both my horizontal and vertical. So I have an x minus 3 for horizontal and an x plus 4 for my vertical. So if I do that box model to multiply each of these four groups, we'll have x squared for x times x, minus 3 times x is minus 3x, x times 4 is a plus 4x, and minus 3 times plus 4 is the minus 12, because a negative times a positive is a negative. So this area is going to be x squared plus 4x minus 3x minus 12. Put those two x terms in the middle. Those are like terms, and they can be combined. So I'll have x squared plus 1x minus 12. Okay, now our final piece to this is, what's the area of the shaded region? So the shaded region would be the large rectangle, EFGH, minus the small triangle, or the small rectangle, ABCD. And we're looking at the area of those. Well, the area of EFGH is 2x squared plus 12x. And the area of ABCD is x squared plus x minus 12. Okay, notice something here. This minus sign, this subtraction is subtracting every one of these terms in the ABCD group. So when I do that, it's like distributing that subtraction. So I'm going to have 2x squared minus x squared. I'm going to have 12x minus 1x. And then I'll have minus 12. So this will give me 1x squared plus 11x plus 12. Whenever you have a 1 in front of an x or an x squared, it's kind of optional. So you could just write this as x squared as well. Let's see if I can get this to erase here. There we go. So this would also be an acceptable answer. So there are going to be like multiple versions of acceptable answers, but generally it has a lot of algebra, a lot of multiplying, a lot of combining like terms. Notice on this last one, particularly like this whole distribute the negative idea. So we have a lot going on there. Okay, so in your notes, talk about box multiplying. In your summary, talk about combine like terms. Also, just refresh on the idea that perimeter is the distance around. Where you add. And the area is the inside. And you're going to multiply that length times width, or that base times height. Okay, so turn that into some sentences. We are going to have a lot of practice related to this, and hopefully that will be helpful as well. Thank you.